This is video log for the Ampex rebuild. So it's the Ampex 6516 theater amplifier, and I'm going to make a few changes in it. So two things: will upgrade the power supply and also add an additional external filament transformer for the heaters. So let's see the parts. So this is the choke that I'm going to use. It's a triad C40X small inductor. It's 0.32 Henry and it can handle 600 milliamps. So I'm going to use much less than 600 milliamps. It means that the inductance will be a little more than what it says here, probably 0.4 Henry or something like that. And I chosen this because it's relatively small and it has a super low resistance. So its DCR is only 10 ohms. So it will have a very little current limiting ability and very little voltage drop. So when here we have C1, C2 of the filter section. So this is capacitor 1 that gets the high voltage from the rectifier. And that's a 40 microfarad DC link capacitor, and through an 85 ohm resistor it feeds the 100 microfarad DC link cap. These are both plastic MKP caps, high voltage caps. And I will swap that 85 ohms for a 10 ohm DC resistance. So it means that the power supply, the speed that this C2 is charging at will be more than 8 times faster. So whenever you hit a base note, then this cap can recharge 8 times faster than what it was currently capable of doing. And because 0.32 Henry is not much of an inductance, for an inductive filtering you usually need at least 1 Henry or 5 Henrys, 10 Henrys to make it more of a choke supply. So it will stay primarily capacitive, but this amount of inductance still offers much greater filtering than this 85 ohm resistor does. So my V plus will go a little bit higher as a result, about 8-10 volts higher. And I will be doing something additional that I wanted to do, because right now I have a 5U4 rectifier that is supplying this capacitor bank, and it's capable of supplying a 40 microfarad initial capacitance, and that's what the original design for this amp was as well, 40 microfarad. However, I also want to be able to use other rectifiers, for example the 5R4GY and others, and actually that 5R4GY, it doesn't like that high initial capacitance, it's way too much on it. And in general you wanna lower input capacitance after your vacuum tubes, because the higher the first capacitance, the shorter the charge cycles are, and it's a bigger drain, a bigger pull on your power transformer. So it will make your transformer ring much more if you increase the capacitance, and also the charge cycles will fall to like shorter and shorter amount of the time. So when you look at it, like this is the voltage, like this your 60 hertz or 50 if you are living in a 50 hertz country. If you have a low input capacitance or maybe a choke input supply, then your supply is charging during the entire time of that waveform. But when you turn into a capacitor input supply, and the bigger the capacitance, then it's going to be like a narrower and narrower part of the half wave when it's going to charge. So basically if you have like a big first capacitor, like let's say like a 200 microfarad or 300 that a lot of tube amps are using with solid state rectification. In that case, the charge cycle might be just a few milliseconds of each 60 Hertz wave. So a few milliseconds here and a few milliseconds there, and that's a brutal load on the power transformer and will make it ring and will create really nasty artifacts for the sound. And your supply is primarily capacitive when you have like 40 microfarad or bigger size. 40 microfarad for your first cap is generally the limit for tube rectification. If you go higher, you are stressing out your rectifier tube and committed to early demise. Most rectifiers are happy with a 20 microfarad input capacitance or lower, and in that case the charge window is considerably larger at 20 microfarad than compared to 40 or 100 or 200. So at something between 10 and 20 microfarad, your charge cycles are reasonable, and you are also providing a reasonable smoothing, reasonable filtering for the for your power supply. Because if you use a choke input filter, then the problem is that your filtering will be much poorer compared to capacitor input, and you will need more stages or way higher inductance to keep your supply ripple free. So let's continue after this.